In this video, we're going to begin our discussion with an inference about two population proportions. So in previous chapters, we've discussed inferences regarding a single population parameter. This chapter we will modify so that we can compare two population parameters. In this section, we will use inferential methods for comparing two population proportions. That is, the response variable will be qualitative. So remember, qualitative or categorical variable classifies individuals based on some characteristic, and a quantitative variable provides numerical measures of individuals. Independent sampling occurs when an individual selected from one sample does not dictate which individual is to be in the second sample. And of course, dependent sampling occurs when an individual selected to be in one sample is used to be able to determine the individual in a second sample, such as the same person twice. Maybe spouses. Those would be examples of dependent sampling. Dependent samples are often referred to as matched pair samples. Okay? So again, it is possible to be matched against himself or herself. Okay, so take a minute or two then to take a look at the two scenarios and be able to determine if it's dependent or independent and whether the response variable is qualitative or quantitative. So stop the video now, answer the two questions, and then continue the video from there. Okay, so what do we have? Certainly it's going to be independent and qualitative. And the second example is going to be dependent and quantitative. Okay, hypothesis testing regarding the difference between two population proportions. Again, we're referring to independent samples. So, suppose a simple random sample of size n is taken from a population where x of the individuals have a specified characteristic. And a simple random sample of size n is independently taken from a different population where x2 of the individuals have a specified characteristic. The sampling distribution of p hat 1 minus p hat 2 given. Now remember, we talked about earlier that p hat is equal to x over n. So we can see where p hat 1 and p hat 2 come from. All right, and is approximately normal with the mean. Don't forget, we talked earlier about the mean. P hat is equal to p. Now here we're talking about the difference, right? So we're going to take p1 minus p2 because it is the difference. Well, we know the standard deviation, we talked about this earlier, is this. Here, this is referring to the error. So we're not subtracting the standard deviations, we're actually adding them together. Okay? Provided that each particular part of the n times p times 1 minus p hat is greater than or equal to 10, and each sample size is no more than 5% of the population size. So the standardized version of p hat 1 minus p hat 2 is written as follows, which has an approximate standard normal distribution. Okay, so computing the test statistic, we can start with the given. The null hypothesis, we will assume that p1 is equal to p2. So I've written out that. And then, of course, I can subtract p2, so it would be p1 minus p2 is equal to 0. So this particular piece ends up being 0. So I'm just left with p1 hat minus p2 hat. Okay? And I can rewrite the denominator. So we now need a point estimate of p because it is unknown. The best point estimate of p is called the pool estimate of p, denoted p hat, and that's given. So making that substitution, we have this. Okay. Again, keep in mind with this, if the p-value is less than alpha, we will reject the null hypothesis. Okay, so let's write out very quickly how two-tailed, left-tailed, and right-tailed would look. Let's start with two-tailed. The null hypothesis, alternative hypothesis. Left-tailed, null hypothesis, alternative hypothesis. And then right-tailed would look like this. Okay, let's take a look at an example then. So economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. He obtains a random sample of 800 urban households and finds that 338 of them have internet access. He obtains a random sample of 750 rural households and finds that 292 of them have internet access. Test the economist's claim at the alpha equal to 0.05 level of significance. So what do we have? We have two populations. It is a proportion. And we're doing a hypothesis test here. Okay? So for urban, I will consider that P1, and the rural will be P2. All right, so let me write out the very first condition that needs to be met now. So the samples are independently obtained using simple random sampling. So for the next two, I need to do this for urban and rural. So let me start with urban. So P hat 1, that's going to be this. Now, let's write out the other conditions for urban now. Okay, so we got to check n times P hat 1 times 1 minus P hat 1 is greater than or equal to 10. So we know the n is 800, P hat 0.4225 times 0.5775. That's about 195.195. Clearly, that's greater than or equal to 10. And then 800 is less than or equal to 5% of the population of urban households. Okay, now let's do rural. So that's going to be what? P hat 2. That's going to be 292 over 750. That's approximately this to 4 decimal places. Now, let me write these two particular conditions for rural now. Okay, so we need to check n times P hat 2 times 1 minus P hat 2 is greater than or equal to 10, which it is. And 750 is less than or equal to 5% of the population of rural households. Great. Now that the conditions have been met, we need to write the null and the alternative hypotheses. So the null is always going to be this. Now, let's look for key wording. We're talking about is greater than. So that will help us write out the alternative hypotheses, which is this. All right. Okay. Now, we need to put this into the calculator, so let's go there now. Okay, so now what do? Go stat, test, and we're going to be going down to number 6, which is 2 prop z-test, hit enter. So the first one I'm going to put in is 338, hit enter. Then it's 800, hit enter. Then it's 292. Hit enter, 750, hit enter, and here we want it to be greater than, so highlight that and hit enter, highlight calculate and hit enter. So the p-value, in this case rounded to 4 decimal places, would be 0.0920. Okay, let's put that on our paper now. Okay, so it's 2 prop z-test. And then again, 338, comma, 800, comma, 292, and 750, comma, P1 greater than P2. And then underneath, p-value rounding to 4 decimal places is this. Okay. Check that compared to the error. Clearly, that's not less than, so we will not reject the null hypothesis. Okay, so I'm going to write out the conclusion below. Okay. So there is not sufficient evidence at the alpha equal to 0.05 level of significance to conclude that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. And again, keep in mind as you're finishing this up, where am I getting these particular numbers from to put in the calculator? It's p hat 1, and notice here the values for p hat 2. Okay, let's take a look at the next example. A study is conducted to determine if the percent of women who receive financial aid in undergraduate school is different from the percent of men who receive financial aid in an undergraduate school. A random sample of 300 undergraduates had 180 who received financial aid, and a random sample of 250 men undergraduates who had 200 who received financial aid. Is there enough evidence to support the claim? Use alpha equal to 0.01 as the level of significance. Okay, so let's write out the very first condition. So the samples are independently obtained using simple random sampling. So again, when we take a look at this, I will do the women as P1, and I will do the men as P2. Okay? So let's do the women first. So that'll be P hat 1. That will be 180 divided by 300. As a decimal, that is 6/10. So I'm going to write the next two conditions down for the women. Okay, so n times p hat 1 times 1 minus p hat 1. We need to check to make sure that's greater than or equal to 10. And in this case, it is. And then, 300 is less than or equal to 5% of women in undergraduate school. Now, we got to take care of the men now. So, men, I will write this as p hat 2. That is 200 divided by 250. That simplifies to 8/10. Now, let's verify the conditions for men now. Okay, so checking n times p hat 2 times 1 minus p hat 2. Got to be greater than or equal to 10. And in this case, it is. And then 250 is less than or equal to 5% of men in undergraduate school. So now the conditions have been met. Let's write out the null and the alternative hypotheses. Well, the null is exactly the same. Alternative, we need to look for keywords. So let's go back. Okay. So in this particular case, I see the word different. Well, what does that tell me? The alternative hypotheses, they're not equal. Okay, so now what am I going to put into the calculator? So it's 2 prop C test. Okay, so again, the very first two that are going to go in is going to be the 180 and 300. So 180 comma 300 comma, and then the next two are going to be those two. 200 comma 250 comma this. Okay. All right, so I'll write on here p-value, but I will show again how to put this into the calculator now. Okay, one more time on how to show this. Stats, highlight test, and again, we're going to go to 2 prop z test, enter. And let's put our numbers in. So 180, 300, 200, 250, and then highlight that they're not equal. Highlight calculate and hit enter. Now, again, because I see an e to the -7, what does that mean? That's scientific notation. So I'm going to write a bunch of zeros out, but I'm also going to put a 4 there. Because this probability isn't 0. It's close to being 0, but it's not 0. Okay, so let's write this on the paper now. Okay, so writing this out. And then, of course, I'll check. Clearly, that is less than 0.01. So we're going to reject the null hypothesis. Okay, so I'm going to write out the conclusion now. Okay, there seems to be sufficient evidence at the alpha equal to 0.01 level of significance to conclude that there is a difference of women who receive financial aid to men who receive financial aid. Now, remember, for this particular problem, what did we end up having? We had two populations with proportions, hypothesis test, and remember the two populations were independent.